Okay, this is part 3 in my series. Let me go, where am I? Yeah, here's my part 1 is here. UniML and category theory products. Products meaning multiplying them together, not products like what a company makes. And then I made a part 2 on UML category theory, and I also talked about YACs. And what is a YAC? It's your, I forget what the acronym stands for. Let me go find it here on my Padlet thing. YACs is, my memory is getting older. My memory is never good. It's getting worse as I get older. Your added color keys. Your added color keys. And what I mean by your added color keys is you could write on a piece of paper. You could film it. In fact, I'll go to that right here. Let me go to my camera view. So here's camera view. You can see my hand. By the way, I'm working through this book here. I can't turn it upside down, right? Is this upside down? Yeah, this is upside down. Is it right now? Anyway, that looks right. Here's my book. I got several books on category theory. This one seems to be good. It's an older one, and you can see how far I've gotten. Not very far. So I'm a novice on category theory, so I'm probably going to get a lot of things wrong. But that's not the purpose here. The purpose is the endeavor, the journey, not how far along I am in this journey. So I'm taking this journey where I'm looking at category theory in light of UniML, and the reason I'm doing that, in part, is I started working on UniML, maybe 10, I mean, it's more than 10, 15, 20 years, I forget how long, decades. And back then, I think there was category theory because this book, but it's an obscure topic. I never heard of it. And there certainly weren't large language models like we have, or chatbots like we have now. So those are kind of later additions that had I known about them then, it would have, I would have incorporated them early into the UniML design. And maybe I've reinvented the wheel here. But actually, when I go to my chatbot, let me go there. Where is Opus? So there's all this here. It keeps saying, no, they're not the same. Category theory and UniML are two different things. You don't want to force fit them together. They're each going to take their own thing, but they're related. And I think I agree with Opus here. So I'm going to put a link to this. So it's just a real long chat, one of many. And it's kind of funny because I've seen not only is UniML evolving over time, but so is the chatbots like Opus 3 or 4. When I started out on it, I forget what it was. It was flattering me and saying, "Oh, that's a brilliant idea. That's a brilliant idea." Then I upgraded it, and it was kind of like, this is awful. Who is this? So the LLMs are evolving too, and their personalities. This Opus 4.8 is a lot more pushback. It's always saying, but I have to be honest with you, da 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 da. But I'm finding it more useful. It was kind of nice, the flattery, I have to admit. But it got old. And little goes a long way, and it went way too much on that flattery. Now, I like the pushback, but it is kind of hard because every time I say something, it comes back, but those are useful, and sometimes it acts as a straight man. So I'll put the link to this chat. And on my Facebook page, you could probably see lots more of these. I don't know how to get there. How do I get to my face? I'm not very adept. So if you go through down on my Facebook post, there's just zillions of links here. But probably a better place to look is go to my YouTube page. And if you go to, where is it? More, 10 more links. So there, if you click on here, there's all my links. Some of them are dead, or some of them are OBE, but anyway, so you could find my Twitter account here, or whatever they call it now, X account, Facebook channel, So it's all here on my channel here. And I cover a lot of different topics. If you go look at my playlist, I have humanoid robots, technology, even a flat Earth video or two, one or two. I'm trying to keep those down. Battlefields of the future, and yeah, I started doing some AI generated what do you call them, thumbnails. They're kind of hokey, and you might say what they call it, AI slop, but some of these are just random. So rather than just take some random video, and rather than do that, I don't spend much time on that. So I'm not going to spend a whole lot of time creating some cool thumbnail. So go back to my videos, different topics, AI music, and whatever. So and there's one of my AI generated thumbnails. It's kind of right. It didn't quite get them right. Here's I show a bot launching a UAV, and I hate the way it goes away from it. I wish it would linger a little longer there. But at any rate, getting back to the topic at hand, let me go back to here on Yaks. I'm on Yaks. So where's my little camera here? This small, where is it? There it is. Found it. So I move this out of the way. And I want to go to explain a little bit more about my idea here of how you could use not a mouse, but a pen to enter data. And I'm just going to pick this pen right here. You can see it's, and so you could put I want to make this color here. It doesn't matter what the color is. You're just saying, here's the color. You may even put a swatch here. Here's the color. And then this color I'm going to use to designate this, what is that? That's a folder. So instead of having to draw the thing in, you sort of outline it, and if the LLM is serving as portals is sort of the operating system for UniML, and it can be an LLM orchestrated with agents and all that stuff. But if it already knows what a UniML diagram looks like, you get a hint, and it can kind of figure out the rest and then start drawing it in itself. So I covered that before. But what I want to cover here is this, is a busy chart, because when you turn a page, it's kind of intimidating because you turn the page, oops, wrong way. This way, you turn the page and it's blank. It's like you lost all your context. It's like starting a new chat. And it's like, I want to keep the old chat, and I'm running a page, but I could try to get a bigger page, but instead of doing that, I just write things on top of each other. And so I want to talk about this temporal separation. Temporal separation is, say I draw this line here, and I've made it sloppy line. And so I did this T1 to T2. It took me that long to draw that line. And later on, I'm going to draw this other line, and oops, I overlapped it. And I started out as T3 to T4. So if I just show this after the fact, the Yaks algorithm could think, I'm not sure if this line goes to here or this line goes to there. It's not clear. But if we recorded these points in frames, it's like this is T1.1, T1.2. So it's a four-dimensional thing. It have the X and Y of where this is, and the T. So we could look at here and say, it could separate, this is what at T, let's just say T7, this happened, and this happened at T20. And this was that's at 7, this was T5 here, and this was T19. So it could temporally separate this line and say this line went like this, and this line went like this, because I'm pretty sure he didn't start drawing this line and then just start to say, no, I'm going to draw that line instead at this point. Now, if you're drawing a road, it could have been that, like a road network. You're saying, I could have done this, and I said, oops, and I add this later. So it's not infallible, but but that's what I meant by temporal separation. So the idea is you want it to be able to read messy diagrams. Why? because it takes a long time, believe me, to make a neat diagram. And I have to start over and I do a lot of racing and spend all my time trying to pretty it up. The idea is I know I don't want to spend any time prettying up the diagram. I just want to capture the thought as quickly as possible, as neat as I can, but it's not going to be very neat. It's going to be messy, and then let the AI and the computer pretty it up. So that's the idea there. And it's kind of hard to read this here. I think it's because I don't have much light here. There's a way to turn on the light. I don't know if I can remember how to do it. Oops. But never mind. I think I covered that topic there. So let me go to my PowerPoint charts. Oh, the other thing I wanted to cover here is notice here my mouse could point to anything on the display. I can point to like this start icon. Here's my OBS icon. I can point up here. That's my Facebook, whatever you call these things, thingy. I could point to here, but when I let me go to my PowerPoint chart here, I could draw a line, shape line. I could draw a line from any point here, but I can't draw the line. My cursor could go to here, but the line doesn't go to here. My cursor could go up to here or down to there, but the line doesn't go. And I'm calling that Windows Tunnel Vision. Windows Tunnel Vision. And so now let me go to the next thing here. Let's see which chart I want to look at. Here, is this what I wanted to show? Yep. Is that my latest chart? No. Here's another chart I did on category theory. Where I took the video, and this is called a bookmark, and this is region of interest. So what I was thinking of is, would it be cool is if the operating, you have to do this, like Windows would have to do this, or whatever the operating system is be able to not just move the cursor to here, like to here, or to like shapes, but also be able to extend the yarn. I call this yarn, like knitting yarn. And this is the region of interest where you could actually draw, take a symbol here. I can't move it over here, over shapes, but it would be cool if I could. So, and I couldn't move it over the video here, but I imported the video as an image, and now I can do it. So when I talk about Windows Tunnel Vision, what I don't want to be able to, the only thing I'd want to be able to do is build an interface where I could extend the yarn from one window to another window and draw. And not only that, if I move the window, say I could put this box around the shape and say I move this, I'd want the box to move too. And so it could, and so there's two ways of doing this. And my earliest videos I made 10 years ago addressed this. And they're just doing it now. I knew they were going to do it. Ha ha ha, I told you so. Okay, pat myself on the back 3 times. 1, 2, 3. Okay, move on. There's two ways of doing it. One is through an API where you actually you have one app talk to the operating system and say, I would like to put a box around this shapes. And you keep track of where that box is. And then I'm going to tell you, and you keep track, you draw the yarn between them. That's one way. The other way is the open claw way. So I kind of came up with the open claw idea 15 years ago. Once again, let me take a bow this time instead of taking myself on the back. I said, eventually the AI is just going to be able to read your screen and do the same thing you do as a human, is just recognize, oh, there's that shapes thing, and do it. And that's sort of like open claw, and the open claw says, okay, so it could figure out, oh, it was here, now it's here, and now it's not there at all. Let's see, because we went something else. Now it's there, not there at all. So it updates the it does the updating of the, it enables you to get beyond Windows Tunnel Vision. It connects the dots. So given that, let me go back to my PowerPoint chart and reopen it. So here's my latest one where I'm trying to look at, it's in my book, what do they call it? Equalizer. So this is the, and I don't quite have this right. In an example, they didn't have this or this equalizer, so I was kind of adding that. So I don't have this quite right yet. I hadn't quite figured it out right. But once again, what I'm doing here is finding out, what I'm doing, looking at the category theory, is using it as a check to see, have I left something out in UniML that needs to be there, or do I have a square peg in a round hole? And I'm finding kind of those, like what I'm finding out in UniML, usually I go look at my past examples. Not here. Let me go to here. Nope, not here. Try this again. There. Here, this is, it's a folder, and there's the name of the folder. The tall boy sandwich is the name of this folder. But you can think of it as a set. In fact, you could treat it as, use it to model a set. You can use it to model a list, or you could say it's not doing anything, it's just a folder. And it's just placed it. Or you can look at it as abstraction. Or the other thing you could do is look at it as a vector. Let me go there, back to my other chart here. By a vector, I mean here, here's the string, here's the pearls on the string. There's different kind of saltiness. There's freshwater pearls and saltwater pearls and brackish water pearls. And they're just different types of pearls that have different drawing rules mainly. And but their location of the string has a pearl reference number, which is broken down to number of fields. Here I just show two of them. We could have 10, 20, 30, how many fields you ever want. It's up to the model builder. And these fields are they're like a vector representation of this, like when you vectorize something in a large language model, and like on a RAG. So there's three levels of depiction here, of a number of levels. One is, I call this outer space. This is inner space. I kind of turn it out. Outer space is huge, but I kind of imagine when you turn your pocket inside out, your pocket's small and the outside world is large. But when you turn your pocket inside out, it's sort of like you think the pocket is the whole world now. And you kind of substitute inside where the pocket used to be is the world. You kind of swapped it. So here's this vast outer space that's been turned inside out. So now it's all it's kind of like TARDIS, Doctor Who. Here's inside the TARDIS, and you might have scroll bars where you could scroll. This might be a huge image, and you're just scrolling around with scroll bars. You can only see a portion of it. And there's the inner space. So you have the outer space view, the inner space view. Then you could, here we have the folder, and then here's the contents inside the folder. Like a set, this would be the elements, and this is what I've kind of focused on learned from category theory. These could represent sets, but not the elements. The elements, they forget. It's like you just forget what the elements are, and they talk about that. In UniML, you don't forget, rather you hide. They're there, you can unhide them, but you could hide them. So you don't forget them, you just hide. Hiding versus forgetting. And my chatbot, let me go back to there. Where's my chatbot? It points that out, not here. There. If you go read through all this prose, it makes a big point about that. And in fact, I had it make a. Sometimes I download the transcript from a YouTube video and then have it comment on it, and then I post the comment back. It's like I just did that here. Let me go to my recent. History. Here.
Hello, everyone.
This is a very good chat. And notice here, I'm going to say read more. I did just that. I talked a little introduction here, and then here's what Opus wrote. And you read, so you go down here, it mentions that. And by the way, I didn't tell it what to write. I told it the topic to cover. So you could see, let me go to my chat. You can see what I told it to write. So let me go to, keeping track of all this is hard. 2 different spaces. So I want to go to here. And so you can see, yes, can you write? Right. I misspelled that. Fortunately, it corrected it. I tend to write things phonetically and then later on think, oops, that's not the right one. A blurb here. I said, write it as if I am not, that's note. I can see I can't type. I never should have dropped typing in high school. I'm still a 2-finger typer. Write it not as if I am speaking, but as you see it, what you would want it to tell. So I'm not telling it what to write. I'm just telling it the topic. And like I told it to add, it didn't say anything about UniML, so I said you might add a short paragraph in UniML. So you can see here, I didn't tell it what to say. So this is actually what, for better or for worse, this is what Opus 4.8 really thinks based on the contents of this long chat we've had, which I'll give a link to. So based on that context, this was what it had to say. So, and it made a big deal about that. It's like, no, category theory forgets, UniML hides, and it makes it easier to unhide. So let me go back to here. So here I'm showing the contents. Like this would be like the elements of a set if you think of this as a set. So let me go back to here. Boom, ba-doom, ba-doom, boom. Sound effects free of charge. So here, this little symbol here, and I think I got it wrong sometimes again, but this means it's hidden. This means it's not hidden. Yeah, when it's hidden, I put it over this side. When it's not hidden, I don't want it in the way, so I push it out of the way to this side. So here, this is a whole row. This is a folder within a folder. It's a subfolder within this folder. But instead of showing the contents of the subfolder, I'm just showing the folder name, row number. If you open the folder, you see row 1, row 2, row 3, row 4, row 5, row 6. And if you open this one, you see column 1, it's column 2, column 3, column 4. And if you open this one up, you'd see pairs like hex 1-2, hex 1-3, hex 1-4, da-da-da. So I'm kind of picking this up here. Now here's another space here, the chip. And the chip, what computations could live in. This is a computational element. Like you could put an LLM here. So think of this as like an agent that can actually do things. And then there's different kinds of pins. The pins are like an interface, defines an interface with your, you can think this is the scaffolding and this is your LLM. You have several of them. You have zillions of chips. So, and this little symbol means you could turn it this way. There's the bow tie, there's the necktie, and there's the pin. So I'm thinking the one of these, bow tie or necktie, I'll probably change my mind which one it is you're reading not, like I said, there's different spaces. There's the actual text here. There's the position on the string. And then there's what the chip thinks. So the chip could look at what the text says. The chip could look at what the vectorized versions, what the PRNs are. It can look at both. So UniML, as a rule, doesn't, the names, you can name it anything you want. I could name this, it didn't change the diagram at all. Just that the text is more for the human, unless the chip was looking at the text. Then it's not just, then it matters. It's going to care what, like if this is, say this is the prompt, and this could be like prompt, and then if you look, open up, like this says the prompt, you open it up and it's got 1,000 words in it. So the idea is it can be vectorized, and when it's loaded as a vector, it means it could be a vector given this using the PRMs, or it could be a vector instead of having to put 1,000 pins here. This is sort of like a serial data bus versus a parallel data bus. It could read the whole folder just from here, so you don't have to put pins. If you have 1,000 white pearls here, you don't want 1,000 pins, so you can just go serial through there. So the thing is, we have all these different views here. We have if you look inside here, you might see C++ code, or you might see an LLM, or you might see a whole scaffolding, or what do they call it? Not scaffolding, but harness, a harness with the orchestrator and agents and all that stuff. It's not UniML. This is sort of outer space. This is inner space, and I call this the dungeon. Code warriors only enter there. Are under the hood. You can think this is under the hood. So different spaces have different purposes. Then also every one of these has a about box, which I'm not going to go into. But the idea is all this comes together into one model, and it has different aspects to it. And then the other thing is you could draw that model, not with a mouse, and my carpal tunnel gets worse and worse the more I use it. But I want to be able to draw it on a piece of paper, on a messy, and then have the computer make it neat, not me. But the computer's going to need some help, some hints, and that brings us back to Yax. The Yax is a way to give it some hints. And you could talk to it, you could draw it, you use colors, you could use motions, gestures. I talked about that in the previous video. Let me go back to here, where this is actually a 3D view, and I can say, no, this runs this way. This line here, I want to fold it up here, where it runs this way until I do my spring break, then it folds up, it comes back down, and then it runs like this. You can't do that with a mouse, but you could do it here. That's 3.5D space. And so you could have your chat box, and you could kind of move it around, like it could figure it out. It's like, okay, this is vertical. So it's hearing the words vertical. It's seeing this. It can see the mouse move around a little bit, and then it says, I got it. This is a 3D image, and you're projecting it down like this because you can't draw this way. But when you project it down this way, I know you really meant this. So, and then the temporal thing, it knows when you drew something, not just where you drew it. And so based on when, it can kind of help connect the dots, like I showed, and reconstruct. And then they could separate it. You could say, okay, you could draw this line and this line is a separate line. And maybe like here, it draws them as separate lines. Now there's one's, say, one swim lane, the other's the other swim lane. Where you could now, they're neat, they're separated. And then the other thing is, how do you, in this video, it's like, how do you build a model? And it's like, do you start here? And it's like, you can, but no, here. Generally, you start here. I want to build a model of a tall boy sandwich. Where do I start? I start with the tall boy sandwich. Then I look at, or maybe other sandwiches. And then I start analyzing it and then importing things. Here, I actually didn't use bookmark. Here's a bookmark. so, but also actually portal. Here's a portal where we run the swim. This is another crosswalk. Crosswalk actually enters this outer space, and runs through outer space, and it's a portal. And then we come out of outer space back into inner space, and where there's no portal here. I mean, maybe there's an implied one, but so we start here. We're going to model the Sawboy sandwich. We start here. Then once LLM learns what UniML is, it could analyze it for it. I call that digestion. It's like simulation, like food. You're going to eat the food. The body assimilates it into proteins, and I'm not a biologist, so I don't know all the details. But it can look at this and says, oh, okay, it recognizes there's the bun, there's the meat, there's the lettuce, there's the tomato. It's like, okay, we're going to start building a UniML model, build a UniML model of this, and then you could then edit it and say, okay, I don't care about this, or I want to do this. You could stack them here. There's different kinds of stacking. And so when you stack them, what you're doing is this is no longer just one swim lane, it's a stack of swim lanes. And you can see that here, there's 7 of them. But you unstack them just by dragging it here, or you could kind of do this here. Select mirror. I don't know if I have to get rid of this, do that. I'll put it here. You could go to, and then say right click, separate, or stack, and all this. So what you're really doing in modern lingo is you're chunking this image into pieces, and then those pieces become objects that you could assign properties and relationships and and then there's different views. These are like C-ROMs. They're icons that C-ROM stands for Common Range of Motion. And what I mean by that is, in computer science, you have like classes and types and all this stuff. And I thought, I want to get away from that. Common range of motion means a flock of birds. What makes a flock of birds a flock of birds? Well, they all kind of move together, a common range of motion. They don't move exactly together. The wings flap differently, and they're not flying exactly parallel flight trajectories, but they kind of move together. So, okay, what about a platoon of soldiers? Well, they kind of move together. If they don't move together, they get dispersed all over the place. They're no longer a platoon. So a platoon of soldiers. How about a paragraph in a book? Well, the paragraph, they don't necessarily move together. What they do, you flip the page, all the words move together on that page. When you flip it, you flip a page, the words don't discombobulate, where some of the words stay on one page and others on the other page, or they fling out into the space. So the words on a page they have a common range of motion. And then here with slides, a bunch of slides are kind of archipelago. You could think of it like a video. Each one of these could be a frame. So you have sort of a sequence of actions in frames, and then you could group them together to make like a clip or a scene. So it could be Act 1, Scene 1 of Hamlet. If you're watching the movie, then you can have Scene 2. You can move these, unstack them. Let me move it up here. Or stack them and move them around, So you can see here, UniML is not category theory, but you can see it's kind of related. It kind of does some of the same things, that abstraction. It's a way of abstracting things, but it's a graphical model. It's by graphics meaning you have a picture of the sandwich there. You start with a picture of the sandwich, and then you have tangos, which I forget what they stand. I'll go find my tango thing here. So, I'm rambling here, but let's see where I want to go to. There we go. Close this. Somewhere there's a tango here. Oops. I want to go back to here. It's hard to find these things. Oh, I can find, I've got an index now. Tangos, where's the tangos? My index is long too. I can't find them here. I'll find them. Here they are. It should be here. There we go. Tangos. Tutor, avatar / actor. I have 2 A's. Narrator, guide, coach. There's a C and a G overlapping each other. I keep adding more roles there. Orator. So, and then I give the tangos personas. And that's just, and they can have different personalities. They can have different, it could be different experts. Maybe Dr. Froome. Oh, I renamed her. I didn't like Froome. I wanted to give her, I was going to give her the name Dr. Frick, Frack, and Frump. But I thought, no, that's kind of insulting because Frumpy. So I didn't want, so I renamed Dr. Frick, Dr. Frump, and Dr. Froome, Dr. Frick. So it's kind of confusing, but regardless of the names, and I had to give them the names because the AI would get them confused. And so there's an important thing. They have mouths, they could speak, they have fingers, they could point, and then they have a personality, and they can have an expertise. Maybe Dr. Frick and Frack, Dr. Frick is maybe the scholarly one, and maybe Dr. Frick is practical, and maybe, or whatever, and maybe Dr. Fruit, whatever. They might have different personalities, different roles, and they can change roles. They have them hats. So they can change hats. That's kind of their roles. So what I'm building here is like, well, that's kind of goofy. It's like, yeah, it's kind of goofy, but but there's purpose here. It's to help you get your mind around if you know what these are. If I use total abstractions, let me go back here. I started out with this. Go up here. Just before I had these, I just had call outs like, hello, I too am a UniML comment. This is a comment bubble. And it could point with this little finger there. It could speak, but it's not an embodiment. It's just the text. And later on, I thought, oh, that's pretty cool, and we could do those. But rather than do that, we could do better than that. We could have it, and here I could say like a dialog box. We used to have those chat. This kind of went away. Some of the stuff's dated. A lot of it's dated. Instead, we could have the Tango has all those same features. It could point, it could speak, but it also has a body, embodiment, which just gives it more pop, makes it easier to see. It can be animated, so it can move its fingers around. It's easier. It's more eye-catching. It catches your attention. You don't have to search for, like a little call out here, a little call out there. So anyway, so all these have. So then when I start animating it, you could have, this is a string. Let me go there. And this is a start of string symbol. And so my videos, these are what I use to make the videos. And so this talks about the different kinds of pearls. Fountain water, I've gone brackish, they're back to brackish water. It started out brackish water, then fountain water. So I changed the names, but there, so you can see all the different things here. This is kind of a float. See, this is a floating when it doesn't have a tango with it. So the tangos make it a lot easier to. Oh, here I have a UniML comment bubble without it, so it points. So it has the same thing. It points here. It's the same as pointing with its finger. It could speak with bubble. It's the same as this bubble, but it doesn't have. What it doesn't have is a body. So it's just. And there's a place for this. You could use that. And then I have another thing, a beeline, where you just do a straight line. And these others have to be routed. You want to route them so they don't get in the way and include things. And then, yeah, you have laser pointers and other things here. So you have. So in UniML, you have what I call. You can have styles and expressions, powerful expressive ways. You can develop your own styles, how you do things. There's more than one way to do something, which lets you pick the style you want to use. So here's a split. See, there's a black pearl, but if the black pearl's hidden by this bubble, we could split it into two pieces so it peeks through. So there's a lot here. So, and I can't cover it all in one video. I can't cover it all in 10 videos. I can't cover it all in 50 videos. But I could show bits and pieces from different perspectives. But the thing is, if you had proper portals, you had a UniML model, I wouldn't have to tell you any of this. You could figure it out yourself just by getting out and using it, browsing and clicking on things. Pretty soon you know how to use it. You didn't have to look at any of these videos. You could just figure it all out. So that's the whole idea, because it's graphical, intuitive, it's context sensitive, it's spatial, blah, 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 all that stuff. So let me end the video here. I've rambled long enough. And I think it's really cool. And this is just a way to do it. It's not the way to do it necessarily. It's a way to do it. But it's a way that I've spent maybe 15 or 20 years, maybe longer, thinking about how to do. So if you're going to come up your own way, great, more power to you. But maybe you want to take advantage of my 15 or 20 years thinking about it, so that you don't start from square one. You can start from square 10, maybe square 20, and then come up with something better. And if you come up with something better, more power to you. Everything can be made better. And but I bet when you come up with something that's better, it's not going to be all that different. It's just going to be some repackaging here and there and a little bit of this. And so my thought is, why bother to do that? I mean, yeah, if it makes it better, do that. But if it's just adds more confusion, just stick to what I have here. Not because pride of authorship, it's just to keep things simple. So you don't have neat. It's like when Microsoft stole Apple's graphical GUI, which they bought legitimately from Xerox, and people at Xerox foolishly sold. They changed up things just to be so they wouldn't get sued, I suppose, by Apple. And it just added. Now, some of the things I like better, like the right-click two-button mouses, which I wish Apple had done. So some of it's improvements. So adding a two-button mouse, and then the scroll wheel. The scroll wheel is really valuable. I use the scroll wheel all the time. So, but what they don't have is when you click here, they haven't figured out a good use for the Z-axis, which I covered that in some past video. How to do that is you hit this and you get some sort of context menu that you can select, and then select from that context menu. But see, what I've had is what they call it multimodal. I could go back to the pictures here, and work for this mode. I could talk to it like I'm doing now. I could do this. I could go back to here. I could so multimodal. Then it could have computational elements like the chips that could actually compute things and do things, agents. So it's multimodal. It's all the buzzwords. Just take all the buzzwords, and it's like, yep, UniML, we can do it all. And so that's kind of what I end with is, I always like that song and from Annie Get Your Gun. Anything you can do, I can do better. Anything you can do, I can do better than you. No, you can't. Yes, I can. I'm butchering the song. But let me go back to what that means here. Go back up to here. No, not here. Here. So what I mean by that is, yeah, you could draw a proper category theory drawing. And I thought, okay, you could do that, but I can do it too, because all I have to do is map. I could take your drawing and I could simulate it. I could create import each element here via a bookmark into from outer space to inner space. Then I could do so much more. And then if you don't care about something, I don't forget about it. I hide it. Like I'm hiding here. This is also a folder within a folder. I'm hiding the contents of that folder. So that means this is over here. This should have been over here. That's what it is. Rotate. No, I had it backwards. This should have been, oh, this is right here. Yeah, this is right. That means it's unhidden. I put it over here out of the way. If I put it over here, if I clicked and had it go over here, however you do that, rotate, horizontal. If you saw this, what would you see? All the contents of the folder would go away. You'd just see this on the string, just that. Or maybe you could add things piecemeal. But we didn't forget what all this stuff was. We just hid it. Or we put a string break in, or we could use a blue pearl, da-da-da. So all that stuff has meaning. I call it UniML speak. So let me end the video here. Like I said, I was going to do it a while back, but let me do it for real now. So end the video, hit stop.